Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good night to our lecturer. So this is our presentation for AI intelligence project. So next slide. Okay, first and foremost, this is about the introduction for our project. In the evolving field of machine learning and image recognition, convolutional neural networks (CNS) and have become a pivotal to their high performance efficiency in handling large scale image data. So our project is about neural networks (CNS). So next, okay, this is the concept that we use in our projects. First is convolutional neural networks (CNNs), LENet 5, LXNet, and dataset. Okay, next. Okay, for the overview for our project is this project involves a comparative analysis of neural network architectures on image classification, thus using the MNIST and CIFAR-10 dataset. So at the end, after this, my friend will present for the task 1, task 2, and task 3. Okay, we go to task 1.
This is the result about the two layer on an for the boy accuracy and the loss force. When I get more about the number of bars we for layer 2 training test get the 0.4110 for the accuracy 0.86. Next, result for the CNN line mode. When the burst accuracy, we get the training test 0.9, where on the burst list validation 0.5. Next, the result line 5 mode for the burst accuracy for training 0.93, on validation 0.989. Next, this the summary about the table for the test one, tax one, the metric for the training accuracy and the training loss, the validation accuracy and the validation loss, test accuracy and loss, test loss. Next, discussion the 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 late night fight the battle on the MNST detail than the base nerve, not NN accuracy. The interfar outperformed the base on the network accuracy. The equivalent the layer of the light 5 use the parameter the sharing and give me the different part of the input image in the same set. The load 5, the increase the maximum bowling layer, which the width, the space, the meter of the input quality or image making is it is lost specific. Next, uh, my friend they talked about the tax too now.
So the task two is we have to perform four model. The first one is result two layer NN. So as you can see that the accuracy is 0.4 is lower and the loss is 1.7. And the next model, this is the output when I try to perform the model by upload the photo of bird. As you can see on the right side, the coding will guess the photo is automobile, which is wrong because it's the picture I used is a bird. Next. So the next model will be simple the net model. And as you can see, the accuracy getting higher and 0.6, and the loss getting lower 0.94. Next. And the result after upload the picture of bird, the coding can guess it correct. So this is the simple LeNet result. Next. So the next one is a LeNet 5 complete model. So as you can see, the losses quite near to the previous one, but the accuracy getting higher. Next. This is the result. Still guess it correct. The coding still guess bird, but as you can see, the accuracy getting higher. Next. So this is the last one. The LeNet 5 modifier model. The total loss get quite high compared to previous one, but the accuracy getting low. Next. Even this model can guess the picture correct, but uh there's a lot of different in the test. Next. So as you can see, this discussion, overall for the second layer neural network, it shows the lower performance limited by its shallow architecture, and the simple LeNet is perform better than second layer NN, but has moderate generalization. LeNet 5 complete model, best performance, strong learning and generation capabilities. The last one is LeNet 5 modifier model, moderate of performance impact by architecture modification. Next, so comparison. LeNet 5 complete outperform all other models, making the best choice for CIFAR 10 tasks. And the second layer NN has the poorest result, highlighting the limitation of shallow network. Conclusion, the result highlight the importance of well-designed architecture in achieving high accuracy and low loss, especially for complex dataset like CIFAR 10.
Okay, so for task 3, we need to recreate the AlexNet. So for AlexNet in reality has input of 227 by 227 times 3 RGB image. But for CIFAR 10, it has 32 by 32. So we need to adjust a little bit uh, the model to fit CIFAR for AlexNet model. So for our recreation, we try to use 4 convolutional layer with a single flattening and 2 fully connected layer. Okay, next. So this is the result for AlexNet recreation where we get test loss about 0.781 and the test accuracy about 0.774. Next. So this is one of the tests where we try to use we try to test the accuracy of the model by using BERT and it successfully guess the picture. Next. So for the comparison for the AlexNet regression, as I said, it has 4 convolutional layer, flattening and 2 fully connected layer. This make it has about 4.6 million trainable parameter, where the training accuracy is about 0.903, while the loss about 0.279. So in comparison with the LeNet 5 complete model, where it has the highest performance among other LeNet, AlexNet is more deeper and complex architecture because it has more convolutional layer, while LeNet is much simpler with fewer layer. So this show that training performance-wise, LeNet fits better with the training data because it has simple it's a fewer layers, so it has fewer loss and higher accuracy. But validation or test performance-wise, AlexNet perform better because it has more convolutional layer thus it has better generalization than LeanNet 5. So what we can conclude about this task that AlexNet is more effective for tasks requiring better generalization because it has less overfitting. As you can see from the training and validation test, it has a smaller gap between the accuracy and the loss, while LeanNet has higher gap, so it shows less overfitting. Next.
So for the lessons learned, the choice of the neural network architecture significantly impacts model performance. And then adapting and optimizing these models requires careful consideration of the dataset characteristics and extensive hyperparameter tuning. And the other lesson that we learned is that the hands-on experience reinforced the theoretical understanding of neural networks and provided practical skills in model implementation and evaluation.
Okay, so for the critical self-reflection, so from this all of this project, we can see that we will use a lot of application on in image classification. While the project is objective were clearly defined, several challenge and areas of improvement we can improve from all of the image classification, such as next slide. Just from the understanding CNN architectures, we will have a strength and challenge when we use also in the technical skill and tools next, and also in dataset handling and also in performance evaluation. So all of these will have a strength and challenge that we can improve in further time. So next.
So for the conclusion, MNIST and Sifatan is used to compare convolutional neural networks and standard neural networks. So the MNIST dataset findings, we find that the neural network achieve reasonable accuracy and the convolutional neural network outperforms the neural network. And this proves that the effectiveness of convolutional layers in identifying the spatial hierarchies in digital images. For the Sifatan dataset findings, it is more challenging due to its intricate and colorful images. Neural network struggles with complex patterns, resulting in lower accuracy compared to MNIST. And convolutional neural network excelled in learning and extracting the features from diverse image structures and contents. And for the last one, for the key insights for this project, the intricacy of the dataset should be considered when choosing between neural networks and convolutional neural networks. For more complex datasets like Sifatan, convolutional neural networks are likely to perform better. And the performance of the model can be improved by tuning the convolutional neural network designs and its hyperparameters. And that's it for our presentation. Thank you.
Thank you so much.